right, next on up, we have Samin from Riverlane who will be talking to us about software stack requirements for quantum computing testbeds. Take it away.
Okay, thank you very much. So I'd rather not talk to you, but this is my 10 minutes to talk to you. I've got a slide at the end where hopefully we can have more of a conversation, an advert for a kind of an event we're having tomorrow. So just wait for that slide. I'm just going to kind of build up to that event. So my name is Samin. I'm head of software at Riverlane. My colleague Tom is here, one of the co-authors. I'm going to talk to you about, as you're kind of scaling up your quantum kind of experiments, your workflow, what kind of tools do you need? What infrastructure do you need? Could be just in your lab, could be something much bigger than a lab. So how many of you are experimental physicists? Actually, I might have the, OK, good enough, yeah. OK, so I think this is kind of definitely appeal to you guys, but I think it'll probably appeal to a lot of other people as well. You know, if you're an experimental physicist, you come into the lab in the morning, you've got 900 experiments to do, or 100 or whatever. You start going through them. You know, you successfully do most of them, and you got all the data, right? Now, 2 weeks later, you come back and you go, OK, I've got all my data, but where is it? What is it? So you look at the lab, you look at the PC that's attached to your control system, if you're a quantum kind of error correction person, say. You look at the PC that's attached to your control system, and you go, oh, no, I've got 900 files here. They're all named something bizarre. They've got a date on them saying, my file number 4, my file number 4 from yesterday. You get the idea, right? So we've all been there. And now you got to go, I need to write a paper. I need to kind of understand my data, but my data is all in a mess, right? You're just using the file system, the lab PC's file system to store your data, right? There's no way to get it out, really. And you might not be the only person in your lab using this control system. So there's other people with their own files. So this is kind of just one aspect, one feature of when you're kind of growing up your lab, when you're going from kind of an artisanal kind of workflow to something more kind of testbed, like where you've got several people, a dozen people in a lab, dozen people in a kind of startup, scale-up, doing quantum experiments. When you're doing that, you really need something more systematic. You need to kind of think, oh, what is my workflow? How do I automate it? You need to think, oh, what is my data? How can I classify it? OK, so the moral is kind of to be able to manage your data and to be able to manage your workflow. So these are kind of a couple of things that we think are really important. And we've built this kind of software stack called Aqueduct. We call it Aqueduct. It sits above your control system. So we've heard the names of a couple of control systems today. It's control system neutral. It sits above your control system. And it basically makes your experimental workflow much smoother and much easier. So Aqueduct, and then your control system, of course, sits above your qubits, right? So you're in a lab, you're running experiments, right? So Aqueduct is a pure software kind of framework. It's kind of written like a web app with a lot of plugin, very open plugin capabilities. You would just install it on your lab PC and use it, right? It allows kind of other high-level applications to run on top of it. So one of the things at Riverlane we're very interested in is kind of our main focus is on quantum error correction. So for instance, we currently have kind of a plugin to Aqueduct that does quantum error correction as a post-processing kind of task. And the Aqueduct will allow you to both plug in kind of your things at different levels of the stack. I want to talk just briefly about some of the features that we have in Aqueduct right now, and some of the things that are coming. So things that we have right now are things like managing your data. So that was kind of the mess I showed on slide number 1. We thought that was a very, very important thing. We've talked to a lot of people using control systems, and it's a very important thing for them to say, oh, I want to classify my data. I want to organize my data. But other things are coming as well that they've said is very important. So like automating your workflow, scheduling your workflow, things like this. So what I'm going to do in the next couple of slides, just show you some of the screenshots from the data management system, and just talk to you about some of the things that are coming. OK, so this is just a shot of what it looks like right now, the data management feature. So if I logged in and I would see my experiments, this is what I would see. So there's like 1, 2, 3, 4 columns here. Every experiment that I ran has a unique ID. That's the first column. I can give it a name and a description. Everything's editable by me. And one kind of very unique thing that we've seen quite a lot of interesting uses of, and kind of creative uses of, are things like tags. So you can tag your experiment as you want. It's up to you. You can then filter on tags. You can kind of search on tags. Kind of one way to organize your thing, your experiments. Yeah, so if I click into one of the experiments here, so let's just take the first one, quantum memory, say, this is what I would see. So I would set up my experiment, so I would give it a name, I would give it some tags, and every artifact that is associated with my experiment would sit inside kind of this area. So data or parameters that are coming into my experiment, I would be sitting here for all in one place. Output from the experiment would also come and sit here as well. So you know where to go to get all of the artifacts that are associated with your experiment. There's a little kind of previewer here. So some of the data types, some of the file formats, you can preview immediately. And others, you might have to kind of save yourself and preview somewhere else. Or if you want to do some more intense post-processing, you would save them off somewhere else and do that there. One of the often requested features has been dark mode. So that's there. It's kind of a bit of a joke, but actually people are quite happy with that. This is kind of a very nicely designed kind of interface that we've worked very hard with our partners to design and for them to use kind of very creatively and very smoothly. Everything that I've shown here has a kind of a programmatic interface. So I think when you kind of begin scaling up, you want to use the UI for some things, but you probably want to use the programmatic API for a lot of other things. So for instance, just as an example of how you'd use the API that we have, so here's kind of on line number 3. So it's just a Python package wrapped up very nicely. Line number 3, you would create an experiment, add some tags. You'll probably submit the experiment, get the data out, and kind of run some post-processing. So all of this will be done programmatically. Yeah, it also shows the last few lines are also about uploading the files as well. And you can upload and download any artifacts that you have in that experiment. Basically, the unit of data management is an experiment. Aqueduct is quite an open architecture. So the screenshot I showed you on the left-hand side, there was a sidebar there. And all we had right now was experiment management. But actually, we see the whole thing as very kind of extensible, very plug-in based. So you can imagine many applications that could go here. HPC integration, so Cameron talked about that. Something like that could go there. Other compilers could go here. And there was a talk about, many compilers mean different things to different people. But you could put those there as well. And I'm only talking here about kind of the UI. But of course, it would all be programmatic as well. Yeah, and then, yeah. OK, so that's the last slide I have. Tomorrow we're running a workshop at 10:30 in the exhibition hall. Aqueduct is open source. It's on GitHub right now. And we'd really like to work with the community to build this out. And we think that this is kind of a very base level of functionality that should be useful for everybody. And by base, I don't mean, I think base is a good thing because it's kind of the minimum features that you'd want to automate your workflow, to run your experiments. And we really want to work with the community to extend, see what is important to them, to link it up to other kind of open source tools that are out there, other open source infrastructure that's out there. So come along. Yeah, it's on GitHub. It's also a Python package, and it's on Docker Hub, the Docker itself. And if you have any questions, that's a kind of a dedicated email site for that. just as an incentive to come to the workshop, we're going to go to one of the big donut places down south of here and bring some donuts. So come along. As you can see, there's no coffee even outside, so we're going to provide the donuts. Thanks. Yep.
Yes, in the back.
How do you capture the metadata about the configuration of your devices that you're doing the experiments with? Like the data of the experiment, how do you capture the configuration of your actual experiment?
Of the control system or of your experiment?
The control hardware.
Yeah. So this is control system neutral, right?
Is this not encoded in the experimental capture data?
Yeah. So there's a generic API that a control system would have to implement, and that kind of packages up the specifics of the control system, right? So like if you want to submit if you want to say, and you can imagine what that API would be, right? So is my control system up? Here's something for the control system to do. So the here's something is very specific, would be specific to the control system. But here you just have a generic API to say, oh, run something on this particular control system.